So in today's discussion we are going to discuss about the concept called Cauchy's residue method. Okay, Cauchy's residue method. This method we are going to apply in Z transform. So we are going to solve the problem and we will understand how Cauchy's residue theorem can be applied in Z transform problems. Okay, in Z transform problems. So actually this is the concept we are going to apply. So you can see the concept of Z transform can be evaluated, can be solved and can be written in this form. That is 2 pi I into sum of residues. 2 pi I into sum of residues. So this concept is an important concept like what we have seen, convolution theorem and partial differential equation. So like convolution theorem and partial differential equation, this residue theorem is also an important topic when it comes to Z transform. Okay, when it comes to Z transform, already this concept you would have learned for Laplace transform. Already you have learned this concept for Laplace transform. So how to solve this? So what is the concept? What will be the question? What kind of structure the question will be? So if you see, the question will be like this: Z inverse of 10z by z minus 1 into z minus 2. So this is the question given. Okay, we have to find z inverse of this particular term. Okay, there is a numerator and also a denominator. Okay, so this is the concept. So here I am taking this concept as x of z. Okay, you can see here I am taking this concept as x of z and I am multiplying this concept with z power n minus 1. So just you compare and see. This is the format. You just compare the question with this. Here, the term inside the bracket. Listen, the term inside the bracket is 10z by z minus 1 into z minus 2. That term I am taking as x of z. So that is the term here. So I am multiplying with z power n minus 1 as per the concept. Because if this concept exists, I can write in this model. Okay. So I am multiplying z power n minus 1 on both sides. Let us assume. So this is your x of z. I am multiplying z power n minus 1 on both sides. Now let us have as it is. You can see the denominator. How many factors are there? Two factors are there. We have two factors here. I think you can just recall how you studied residues in your lower grade. That is in, I think in previous semester, Laplace transform. While solving, you would have discussed this. Z minus 1, z minus 2, you have two factors here. You will take each factor one by one. So first you take z minus 1. So if you take z minus 1 and if you equate to 0, you will get z is equal to 1. Am I right? Z equal to 1. Similarly, if you take z minus 2 and if you equate to 0, then z is equal to 2. So here the whole power is 1. Am I right? The whole power is 1. It is not z minus 1 square, z minus 1 cube. So it is z minus 1 whole power 1. So it is called, z is equal to 1 is a simple pole. It is called a simple pole. Or else, I think you remember, suppose if there is anything in the power, you will write this is the pole of order m equal to 2, m equal to 3. We had seen in the previous discussion. So this is a simple pole because the whole power is 1. Here also it is power 1 and here also it is power 1. So z is equal to 1 or z equal to 2 is a simple pole because both has the power 1. It is a simple pole. So both are simple poles. So using this we are going to find the residues. That is the important concept here. We have to apply here. So how to find the residue? So you can see here, this is the concept. What I do, I take this term that is here. Okay, x of z into z power n minus 1, and I am using the concept of residue. So residue of, so even I can say residue at z equal to 1. Okay, residue at z equal to 1 for this particular term. So that is written here. Residue at z equal to 1 for this particular term. So how it works? You have to apply limits. The concept is here it is limits. Okay, limit z tends to 1. Actually, in general formula, it will be limit z tends to a into z minus a into your this term. This is nothing but this term. Okay, this result. So into x of z z power n minus 1. This is the general formula. This is the general formula. So what we are doing here is, in order to find the residue, we are taking this concept, this general concept, and we are applying what we have in our question. Okay.